Okay, this is section 6.5, some more notes. And what we're going to do is we're going to actually derive the general logistic formula. And you'll use this technique in some of the homework problems. They ask you to actually use partial fractions. So this is the technique you're going to use with some specific numbers. We'll try to do some of those a little bit later, but let's just kind of go through this general formula because this is part of your notes for the section. So we have dp dt equals kp m minus p. Remember, this is the carrying capacity m, and this is the whole limiting factor. So if we want to solve this, we know that dp dt, we can move the t up in the top, and then we can separate the variables some more. And I can put with the dp, I can put the p mp over here and keep the k with the dt. That's a constant, so there's no problem there. And then I'll just take the antiderivative of both sides. And this is okay, this is just going to be kt plus c, but this one I'm going to have to use partial fractions. So we'll call this, so we'll just take a look at this. I'll do this partial fractions in green over here, then come back to the equation. So we'll say this is a fraction 1 over p times the factor m minus p equals a over p plus b over m minus p. And then I can put these over a common denominator, a times m minus p plus b times p all over p times m minus p. So since these fractions are equal and since the denominators are the same, the numerators will be the same. So this is my setup. And then I try to zero out one of my factors. So if I put p equal to 0, this will zero out, and I have 0 here, so I've got am equals 1. So a equals 1 over m. And then I'll use m here to zero out the a, so m minus p equals m. M minus m is 0, so that zeroes out the a, and I have b, and p is m, so b times m equals 1. Divide both sides by m, and b also equals 1 over m. So now I've got my fractions all set up. So I've got, this is my a over p is 1 over m over p, and b over m minus p is 1 over m minus p. Okay, now this is an interesting setup. Now we've got this, and this is going to be kind of hard to deal with. There's lots of ways to do this, but this is the easiest way. Multiply both sides by m. It is a constant. M is a constant, so I could actually take this 1 over m and I could bring it out in front. Then if you multiply both sides by m, that will cancel. So I have this, which becomes real easy. M times that is 1, m times that is 1, and m times that is m kt, and then m is just absorbed in the constant. So now we've got this. Okay. So now we're going to take the antiderivative of this. So let's take a look over here. So next page. And we're going to use the natural log, so that's going to be 1 over u du. 1 over p. So p is u, or the derivative of p, so the derivative of p is just dp, so that's no problem. But 1 over u is m minus p. The derivative of m minus p is negative 1 dp. Well, I've got the dp, but I don't have the negative. So to put a negative here, so I've got to put a negative in front, because a negative times a negative is a positive. So we're doctoring it up, so we don't have to do a whole u substitution to do that. And this was my antiderivative of the kt. Show that over there. I hope I emphasize that. If we go back to this page, I actually went up here. If I took the integral of k dt, I got that was equal to kt plus, then I could actually write it up here. That equals kt plus c. So I just brought that part down. That was easy to do the antiderivative. So I just brought it down here, and then I multiplied by m, so I had that. Okay, so we're back over here. So this is the natural log of p, negative the natural log of m minus p, and that equals my m kt plus c. Now we're going to want to have this binomial on top. So we can simplify this and make it a lot easier. So we just multiply everything by a negative. So this becomes positive, that becomes negative. So I reverse the order. Negative, positive, negative, negative. Now, the negative of C is going to be absorbed eventually anyway, so you don't, it could be positive there. It won't make any difference. Okay. So we've got natural log of m minus p, okay, minus that. So the difference of the natural logs is the natural log of the quotient. So we'll write this as a quotient. And this is still my negative mkt negative c. Now remember, m and k are positive. Keep that in mind. Okay. Now I've got this logarithmic equation. I can change it to an exponential equation. What's my base? My base is e. This is my exponent, and that's my answer. So e to this whole exponent equals m minus p over p. Okay, so I hope that makes sense. Okay. Then I'll break this up. M over p minus p over p, which is 1, equals, again, this. And then what I did was I broke this up from e minus mkt minus c, then made this e to this power times e to this negative c power. Okay. And then we'll call this e to the negative c a. So that's going to be a new constant, depending on the initial conditions. All right? And then we add 1 to both sides, so we have m over p equals this. Now I can multiply both sides by p now, and I can put the a in front. So this is 1 plus a times e to the minus mkt, and this is times p, because I multiplied p on both sides. And then I can divide both sides by this binomial factor, 1 plus a e to the minus mkt, so I have p equals m divided by 1 plus a to the e to the negative mkt. Oops, sorry, right down there. Okay? So again, I multiplied p times this binomial, and I move the a in front. Then I divided both sides by this binomial, and I have m over this binomial, 1 plus a e to the negative mkt, and that equals p. All right? And then that is the general. So what we did was we derived the general logistic formula. Okay, the general logistic formula. So if we have this growth differential, kpm minus p in parentheses, then the solution is this, p equals m over 1 plus a e to the minus mkt. This is kind of like our other solution. Remember the solution for dy dt equals kp was y equals y sub 0 e to the rt. So that's basically the same idea. This is our solution. Where k is a constant determined by an appropriate initial condition, a is a constant determined by an appropriate initial condition, a. All right, that's where that comes from. The carrying capacity is m, and notice where the carrying capacity fits here and here, because you're going to have to know this formula really well and what goes where, and sometimes they disguise it. And the growth constant is k. Okay, that was my growth constant there. And the carrying capacity m and the growth constant k are positive constants. Okay, so that kind of sets you up, and those are things you need to know. So I hope that helps. And you should be able to derive that formula on your own.